So on the bench today we have this interesting piece of kit that I picked up today, again at my surplus electronics recycler. It's got a calibration date, it looks like, of 11/4/94. Various stamps on here, lot number, and I believe that's probably the last calibration date, 11/4/94. It's just an unassuming gray box with a couple of hinges. If we take a look inside, we find the heart and soul of it. I don't know if you can see this or not. It's a Smalltronix, which is an interesting name. Model 673D Milli-ohm-meter, which actually makes it kind of cool. There's a calibration tag here from, again, actually from 2/4/94. The scale on it's quite interesting. It's got this interesting switch that actually, of course, switches to the 0.005, 0.01, 0.51, and 5 range. I'm assuming that feels like a potentiometer, probably wire around back there based on what I feel. Interesting piece of kit. It had this really cheap set of leads in it, which are not the correct leads for this. You can see on the probes that there's probe 1 and probe 2. My guess is these are for Kelvin probes, where there's a sense line and a power line out to your resistive load on each side. That is my guess. Looking down, I'm pretty sure those are boron copper down inside, so they're nice binding posts. It is the largest chicken head knob I've ever seen. Smalltronix. Serial number 2173. I'm hoping you can see the ohm scale here. It's got 0.0002, 0.0004, 68, and 0.001 ohms. So that's literally, it's a milliohmmeter, but that's literally 200 microohms, 400 microohms, etc., which is quite interesting. We flip it back up and take a look in the bottom compartment. And I realize the as is $25 written on here does say 25. I got it for $5. Talked with the manager of the store. He was just trying to get rid of a bunch of old stuff like this. What we find in the base here is actually quite interesting. And again, a test of the age of this thing. Find a couple of Ever-Ready 1.5 volt dry cell batteries sitting down in here. My guess these are very dead. I don't know that. There is some corrosion on one of them here. But I'm going to go ahead and release these. Interesting enough, the batteries are in parallel rather than series, which makes me think they were after current capacity. With 2.5 volt dry cell batteries in parallel, you should be able to develop quite a bit of current flow. I don't know what the rating on these is, or if it's even on here. It's a type EV6, date code 7th week in 91. Nothing in here gives me an amp hour rating. Made in England. That one's awfully tight. Let's see if I can get the. And this terminal here is rather corroded, which makes me think this battery may have leaked. I need a better pair of pliers for that, just because of the corrosion. It's going to be stubborn. Now let's try and determine. There it went. See, I'm guessing this battery has potentially leaked. I guess technically I really don't need to get this terminal off. Yeah, that pole of the battery is loose. It has certainly leaked. I don't know if you can buy dry cell 1.5 volt cells like this anymore. believe. And they're both somewhat sloppy down inside. Now, of course, I'm already dropping the little brass. Heads off the battery. It's interesting where the battery terminals come in. It's just a couple of lugs. There's some kind of insulating tape here. And just straight through the metal box. Into the back. Go ahead and close that up. Just make sure we're recording here, and we are. And we'll see what it'll take to open this guy up. Looks like there's just the 4 flat heads. Side I, of course, expect to find a potentiometer, multi-pole switch, meter movement, some precision resistors. The fact that it runs off a 1.5 volt, I don't necessarily expect to find dead bugs. Any kind of active electronics, although I guess there could be some kind of amplification perhaps. I don't think it would strictly be needed, though I could well be wrong. Don't really know that I need a Milli-ohm-meter, but you know, for $5 I couldn't pass it up. At a minimum, I thought it would make an interesting teardown, so it has come loose. And that's pretty much what I expected to find inside. Power leads come in. There's some 83, 77, 73, 58. I'm assuming those are resistors, or ohmages 78. That one's not labeled. There's a heavy duty, so it's 6 ohm, a rheostat there, and then a potentiometer behind it. The potentiometer is coming off of the power switch, and it's interesting that the rheostat and the potentiometer are ganged together. I don't know if you can see the mechanism here. Got the rheostat down here and the potentiometer above, and there's a coupling here that couples the potentiometer to the rheostat. So this has got to be a current shunt here, so I'm looking at the wiring here coming in. The battery lead comes directly to this post. Those are definitely beryllium copper, the color on them. Not sure what year it was manufactured. It was last calibrated in 94, which would make it a 24 year, minimum of 24 years old, and those are still just as clean and brilliant as they were the day they were made. There's no corrosion. I'm guessing this is the current shunt for the ohm meter. And these resistors create the range selector network. There's a test switch here, which could probably be cleaned. A power switch that just goes to the battery negative and into the active circuit. And the meter movement. And there's a 100 ohm resistor directly across the meter movement here. So that does say 100 ohm. I'm not really finding anything with a date code I recognize. The rotary switch is rather interesting, and that it really is multi-position, but only the 5 positions are used. The rest look like they just leave it open circuit. Yeah, nothing's jumping out with a manufacturing date code. It looks like on the rheostat, 10th week of 86. So the build was most likely around 1986. Looking on this other switch body to see if there's a date code on it, and there is 14th week of 86. So the green switch body here is 18th week of 46, and the rheostat is 10th week of 86. So that kind of confirms this was built in 1986, 87. Nice and simple. Not a whole lot here to go wrong besides dirty contacts. This range switch is a very nice feeling switch. I could look at a couple of these resistors here and just get an idea if those are precision resistors. Find my Kelvin leads. In the sea of patch cords. I believe that's the set of Kelvins. So Kelvin leads, just an example here, refer to a set of leads like this. I've got my positive leads, and you'll notice there's two connectors on the positive, and I got my negative, or the black, and there's two conductors to the black. And what's happening here is one of the connectors runs down to this side of the switch, the other one runs down to this side of the switch. And essentially what you do is you, through two of these, red and black, you're going to pass your current to measure the resistor with. So you pass a known current through to measure the resistance. And then you use the other black and red lead, wherever the black lead is, use the other pair as the voltage sense. And so you read the voltage on this set of leads. And where you're reading the voltage back, the current flow is very, very small, so there's very minimal loss, lead loss, whereas there can be voltage drop across the leads here because there's some current passing through them. So it's a way of getting really accurate 4-point measurements. They're Kelvin connectors, they're 4-point probes, etc. So I'm going to attempt to untangle the mess of cords here because these things are always completely tangled. My Rigol 305080 does support, wow, these are really tangled, does support 4 probe measurements. Let me go ahead and plug these in. Plug the other set in, and I know this is off camera, you can't see this. Let me go to Ohm and 4-wire. Let me see if I can pan the camera up a second so you can see this. Don't know if you can see it up there or not. You really can't, it's behind the lid here. Up there high, well, it's not really going to show up. Too much stuff in the way. But up here high is the meter with the leads plugged into it. Let me swing the camera back down, and we'll look at a couple of these resistors. So this one's labeled 78. It makes me think it's probably 78 ohms. We'll find out here. Nope, so it's actually 3.6 ohms approximately. Actually, I didn't zero this. Let me get this zeroed. Actually, it's zeroed really well. It's down at 0.001, 0.002 ohms. So those numbers are just manufacturing numbers for where the locations of the resistors were. We've got 7.7 ohms there. So these are just really low value, pretty high current resistors. I mean, looking at the bodies on them. That one's at 1.5K, that's impressive. Well, Rosie's choking back there. 1.5K. Come around to this guy. 196 ohms. So anyhow, those are just range select. We've got obviously this large current shunt here. If I can get onto it, which measures in the range of 0.15 ohms through this current shunt. Well, anyhow, I think I will bolt the front back on this. We will give it some power and see what we get. Actually, it would help if I put it on correct orientation. Interesting, it's got a rubber gasket kind of between it is a metal box, and it's essentially got a rubber gasket around the top lip here. I don't know that it's meant to be explosion proof. Based on the size of the resistors in there, it looks like this thing is potentially meant to move significant current. So I'm just going to power it off of my Rigol bench power supply. Of course, I don't have a set of Kelvin leads that'll plug into these binding posts. Damn. So I don't have a set of leads I can directly plug in here. To make this easy to do, it's always got to be difficult. Now let's apply some power to it. See if we can get it to wake up and do anything. I think of the best way to do this. Got the Rigol supply on. Going to set the output voltage to 1.5 volts. Power switch is off. It's certainly not meant to be particularly easy to use here. It doesn't set very flush. Don't think I have any tape handy, and I don't. Well, I'm just going to trust. And if those short, the power supply will go into compliance. Turn the output on. Now, I don't know if these need to be shorted. Actually, we know they do because the ground, there's no power getting to this without probes in it. So that's the first thing. And since I don't have a set of probes in this case, I can just pop in here to use as Kelvin probes. I will do a little bit of cheating here. For now, this is obviously not going to be accurate, but we will connect. We'll take this horrible little set of probes that were in the box, which we know are worthless. Oh, now Rosie wants to do something. And we'll plug those in. And we've got deflection on the meter, but in the wrong direction. I did go, oh, you see what I did here? Can you believe I was that stupid? I can. This is why the meter was deflecting the wrong direction. That was just pure brilliance. Luckily there was nothing in there to destroy. Do not adjust to red line. So I don't know if the red line is where the cal adjust is supposed to go to. I'm going to assume it's meant to go to there, though I don't know that. It's actually labeled milliohms. Is this actually 0? Nope. Again, I'm guessing at the operation. It's interesting. I mean, you can see the needle dance just as I rub the probe tips here together. It's very sensitive. And I'm guessing if I come down from the 5 ohm range to the 5 milliohm range, it certainly pegs the meter out. I don't like the meter being pegged out like that. Yes, Rosie, I hear you. See, without the manual, it's hard to know exactly what I should be doing here. And without a known resistor, I would have to go dig and look for some fixed resistors. I've got some precision resistors. I'll go dig and see if I can find a couple. So I've got some current sense resistors here, some 0.1 ohms and a couple of 0.01 ohms. And I guess we'll attempt to measure one of these and see what we get. Again, this is going to be a really inaccurate measurement. I don't have the right probes. Now that's supposed to be 0.01 ohms. I'm on the 0.01. I'm not exactly zeroed. So full scale there's 0.05. Obviously I'm doing something very wrong. Again, I'm guessing at how this is meant to be used, and I may, the way I've done the probes here may be completely incorrect. I find the scale on that mystifying. It seems backwards to me. I mean, open shouldn't be 0 ohms. And I'm assuming when I short the leads together, it's meant to be zeroed out, but maybe it's not. So with the lead shorted, it's drawn 180 milliamps. That's interesting. Don't like that test mode. It just pegs the meter. That should be the 5 ohm scale. Again, I don't really know. Obviously, I'm fumbling here. I haven't looked for a manual. So that's measured around 4.1. So I'm on the 5 ohm scale. And I'm going to take that where it's pretty. Oh, Rosie, you're a twerp. Going to get that pretty close over the 4 from my point of view. And if I measure the resistor, it does come in just under the 4, and this would be 0.01 ohm. So if that was a 1 ohm, yeah, the movement of the meter is exactly backwards to what I expect, which means I'm not understanding something. But we do know it has a chance. You know, there is some basic functionality here without looking for a manual and understanding the proper usage. It's hard to say whether it actually works or not. Don't know. Anyhow, I thought it was an interesting piece of kit, and for $5, I couldn't pass it up just for a peek inside. Interesting. Now, I will button the box on it back up. And I guess this is going to be a relatively short video, which is okay. You know, it's definitely, in my opinion, meant to move some current based on these large dry cell batteries, 1.5 dry cell batteries, and 2 of them in parallel. It's definitely a sign that it could move some current. I'm sure it's actually meant to be used sitting like this, which of course doesn't make it very camera friendly. 1.5 volt dry cell. Yep, no other indication besides just big blue dry cell. Well, I hope you found something in that, at least a little bit entertaining. And we'll talk soon.